In this lecture, we will cover the CFA Level 1 reading on forward markets and contracts. This is a relatively short reading with 3 sections: an introduction, followed by a description of the structure of global forward markets, and then the major part of this reading is section 3, where we will talk about different types of forward contracts. First, the definition of a forward contract. A forward contract is an agreement between two parties in which one party, the buyer, agrees to buy from the other party, the seller, an underlying asset or other derivative at a future date at a price established at the start of the contract. The way you can think of this is that a forward contract is a piece of paper. That's why it's called an agreement or a contract. On this contract, we write some important pieces of information. We specify what the underlying asset is. Let's say that the underlying asset is a share of General Electric. So one share of General Electric. We will agree on a transaction price. Let's say that price is 50. A maturity date of, let's say, 31st December 2013, and then there will be other pieces of information. But the name of the underlying asset or an identification of the underlying asset, the forward contract price, which here is $50, and the date when this contract expires. These 3 pieces of information are critical. So in other words, at time 0, two parties are entering into this contract. The underlying asset is one share of General Electric, and the transaction date is 31st December 2013, which is specified on the contract. So on this date, one party, which is called the short party, will be responsible for delivering this share to the long party. The long party is the party that is entering into the contract to buy the underlying asset. The underlying asset is one share of General Electric. So long is getting into the contract to buy, and the short is getting into the contract to sell. Now, regardless of what the price of the underlying might be on this date, the long will pay 50 and get the asset. So if the price over here on 31st December is 60, then the long benefits because the long will only be paying $50, which is what is specified in the forward contract. The way I have described this forward contract, it's a delivery contract because the short is responsible for delivering this particular share. But if the long and the short parties agree, then this can be a cash settlement where on expiration date, we can look at the difference between the market price and the contract price, and then the net amount is given. In this particular example, if this were a cash settlement, then the short would give the long $10 and the contract will be closed or settled. Cash settlement is also called a NDF, which stands for non-deliverable forward. Default risk is an important concept that you need to understand in the context of forward contracts. The high-level statement is that default risk does exist in forward contracts. If we go back to the example that I was just talking about, let's say that at expiration, the share price has gone up to 60 and the short party does not deliver. The short party does not deliver the stock for the agreed upon price of 50. Then this is a default. The risk of this happening is called default risk or credit risk. Now, at any given point in time, the party that is winning faces credit risk. So if this is time 0 and somewhere during the contract, let's say at the midway point, the price of the underlying has gone up to 65. If the contract price is 50, then clearly the long party is winning because the way things look right now, the long will have to pay only the contract price of 50 to get an underlying asset which is currently at 65. So the long party has a certain value. That piece of paper that gives the long the right to buy the underlying for 50 is valuable. In level 2, we will learn how to calculate that value, but at this stage, you simply need to recognize the fact that the contract has value. So the party for which the contract has value also has some credit risk or default risk. The other party, the short in this example, does not have any credit risk or default risk at this stage, but there is the potential for credit risk in the future, because if the stock price dips to, let's say, 35, then the short party will be in the winning position and the short party then will have credit risk. Now we will look at how to terminate a forward contract. There are three methods that you need to be aware of. The first method is that one party pays the other party cash and essentially buys its way out. So if we come back to this example, let's say at the midway point, the underlying stock has gone up to 65. So the long is winning. If the long party and the short party agree that the short will pay, say, $16 to the long and close the contract, then this is one way of terminating the contract, as long as both parties agree and settle. Another is that the two parties get into an offsetting contract. If you were the long party, and that means that you are in the contract to receive the share of General Electric here at maturity, with the same counterparty, you can take a short position, which means that you are in a contract to buy an asset and also in a contract to sell the asset. In other words, effectively, the two contracts cancel each other out. These are called offsetting contracts, and this is another method of terminating a forward contract. Let's say that the counterparty does not want to do either of these. Then what you can do is get into an offsetting contract with another party, which means that with party A, you might have a long position. So you are long, party A is short. And then with party B, you take a short position. So as far as you are concerned, your situation or your contracts are offset, because with A you are long, so A is going to deliver the asset to you, and with B you are short, so you are in a contract to sell that asset to B. But with this situation there will be credit risk, because you have a contract with two separate parties. With scenario 1 and 2 there is no credit risk. A vast network of dealers make the forward market. This is also called an over-the-counter market. The dealers are mainly large banks, but we also have some non-bank institutions such as Goldman Sachs, which might also be derivative dealers. Some dealers specialize in certain contracts. For example, if you look at Exhibit 1, you will see a certain set of dealers who specialize in euro-dollar forward contracts. There will be others who specialize in LIBOR-based contracts and so on. You don't need to memorize the information here, but just recognize the fact that some dealers specialize in particular kinds of forward contracts. Typically, dealers who engage in forward contracts also then do other kinds of derivatives. Here is the definition of a dealer: a financial institution which makes a market in forwards and other related derivatives. A dealer can deal with an end user, which is typically a corporation or a non-profit organization or a government. Now, a situation such as the following might exist, where you have an end user. Let's pick General Electric again. If General Electric is going to receive 20 million euros from a European subsidiary and wants to hedge that risk, then it can approach a dealer, let's say Merrill Lynch, and take a position such that it hedges its foreign currency risk. Now, if the dealer, which stands ready to take either side of a contract, wants to hedge that particular risk, it might contact another dealer, and with this other dealer, it might take the opposite position. So, for example, let's say in my euro example that General Electric is taking a short position on the euro, which means that the dealer would take a long position. But if the dealer wants to hedge this long position, it might get into a contract with another dealer where this original dealer, Merrill Lynch, might take a short position, and then this particular dealer takes a long position. So in my example, what dealer 1 has effectively done is offset the risk. And in this particular scenario, dealer 1 did not want to assume that risk. If dealer 1 is fine with that particular kind of risk, then it will not offset. Now we come to section 3, where we will discuss different types of forward contracts. At a high level, here are the contracts that we will discuss. Note that the curriculum focuses on financial derivatives or financial forward contracts. We can also have forward contracts on non-financial products, but those are not covered over here. From an exam perspective, here are the 3 categories that you need to be on top of. Let's talk about equity forwards first. An equity forward is a contract calling for the purchase of an individual stock, a stock portfolio, or a stock index at a later date. The General Electric example that I started this lecture with would be an example of an equity forward contract. So you have 1 share of General Electric and you know that you want to sell it at the end of the year, but you want to lock in the price today. So you can get into a forward contract where the price at which you will sell the share is 50. We specify the date where this contract expires, and we specify the underlying asset, which here is General Electric. So on 31st December, you will sell the share for 50. In this example, you are taking a short position. If the share price goes down to 40, then in the context of this contract, you will benefit, because even though the market price is 40, you will still sell at the contract price of 50. If instead of General Electric, we consider a portfolio where you have this portfolio of, let's say, 5 stocks, and you don't want to sell this portfolio today, but you are concerned about the stock price or the value of this portfolio going down, what you can do is approach a derivatives dealer and get into a forward contract where you will sell this entire portfolio for a particular price at a particular date. Given that this portfolio is known to both parties, so we know each share, we know the number of shares and the value, the 2 parties, you and the dealer, can come up with the forward price. That will be the price at which you can sell this portfolio. Now, typically contracts such as these, equity forward contracts, tend to be cash settled. So you will not actually sell the portfolio, but you will make money if the portfolio value goes down. And this is a classic situation where you might be a large institution, you do not want to sell your shares for various reasons, but if you are concerned about the share price going down and you want to hedge against that risk, then you can take a short position with a derivatives dealer. The final scenario is a stock index. If you get into a forward contract on a particular portfolio, the transaction costs might be relatively high because this might not be a very liquid portfolio. If this portfolio generally moves up and down with an index such as the S&P 500, and you feel that by and large taking a position or getting into a forward contract on a S&P 500 index would hedge your risk, then it would make a lot more sense to get into a forward contract where the underlying is the S&P 500. The advantage is that since the S&P 500 is a well-known index, the counterparty or the dealer will be much more willing to get into a forward contract where the underlying is the S&P 500. The transaction costs here will be much lower. So it might make more sense both for you and the derivatives dealer to get into a contract where the underlying is the S&P 500. As a high-level point, when you are getting into equity forward contracts, you should consider the impact of dividends. And here we are talking about dividends which will be paid during the life of the forward contract. The specific impact will be studied at level 2. Here is a simple example of dealing with equity forward contracts. Let's say you get into a 90-day forward contract. So this is day 0. The contract expires on day 90. The underlying is the KSE 100. The forward price is 10,000. We need to always specify a notional amount when the underlying is index. Let's say that in 90 days, the index has gone up to 10,500. If you take a long position, then you benefit. If you have taken a short position, then you lose out. Now, how do you figure out what payment is made? In this case, the short is going to make a payment to the long because the underlying has gone up. And we figure out how much the underlying has gone up in percentage terms. So the underlying has gone up by 500 divided by 10,000. And then we multiply this by the notional principal of 10 million. This amount that we calculate is the amount that the short will have to pay the long. Once you do the calculation, you will see that the amount is 500,000. Just like we have forward contracts where the underlying is equity, we can also have forward contracts where the underlying is an individual bond or a portfolio of bonds. By and large, equity forward contracts and bond forward contracts are quite similar, but there are a few subtle differences that we should keep in mind. Bonds mature, therefore, if we have a forward contract where the bond is an underlying, the forward contract must expire before the bond matures. In other words, if you have a forward contract on a bond which matures in 3 years, then obviously the forward contract should expire before 3 years. With stocks, we need to consider dividend payments during the life of the forward contract. With bonds, we need to consider coupon payments. If bonds have special features such as call options, put options, or conversion options, then those need to be considered when we come up with forward contracts. You don't need to know details at this stage. However, you need to recognize that when dealing with treasury bills, which are zero coupon bonds, that these instruments are quoted based on a discount rate. In other words, if you have a 90-day T-bill which is quoted at a discount of 4%, this means that if the par value is 100, then the current price is quoted based on a discount. The current price is going to be less than 100, and we are going to do this calculation on the next page. The 4% needs to be de-annualized to a 90-day rate, and then we figure out the actual price 90 days before maturity. Let's look at this scenario. You enter into a forward contract here on day 0, which calls for the delivery of a 90-day T-bill in 60 days. The forward contract expires in 60 days, and the idea here is that after 60 days, you will get a 90-day T-bill. If the price quoted on the forward contract is 98.95, that means that when this contract expires on day 60, you will pay 98.95 to get this 90-day T-bill. In other words, you have effectively locked in a rate because this T-bill is a zero coupon bond. It's a pure discount instrument. So when you get this T-bill, essentially after 90 days, you are going to get 100. And if you are buying this instrument for 98.95, you are locking in a particular rate for the 90-day period. So you enter this contract. This is the price that you will pay. 60 days later, the 90-day T-bill is quoted at 4%. So have you won or lost? Let's do some calculation. If the 90-day T-bill is actually quoted at 4%, what is the price? And for that, you need to do this calculation, which we have seen in quantitative methods, corporate finance, and fixed income. The 4% bank discount yield is written as 0.04. That is equal to the discount amount divided by the face value, which here is 100, multiplied by 360 over T. This is a 90-day T-bill, so the time is 90. When you do the calculation, the discount will be 1. So the discount is 1, which means that the price is face value minus 1, which is 99. So you are buying an instrument for 98.95 and the actual market price over here given the market rate is 99. So on $100 par, you are benefiting by 5 cents. The next part of the question is, in general, do you benefit if rates are higher than expected or lower than expected? If the contract is set up this way, where you have locked in a given price, then think about what happens to the bond price with different rates. If interest rates go up, then the bond price or the T-bill price actually comes down, and you've seen this in fixed income. So let's say that the rates go up a lot and the price actually comes down to 98. Then you are not better off with this contract because you are paying 98.95, whereas the market price given high interest rates is only 98. So you will not be happy if interest rates go up. On the other hand, if interest rates go down, then the price of the bond will be up. So let's say if the price of the bond is 99.5 because interest rates went down a lot, then you will be happy with this contract because you are only paying 98.95. Coming now to euro-dollar time deposits, LIBOR and Euribor. You have seen this concept before in fixed income, but we will cover it briefly again over here. There is a large global market for time deposits in various currencies. The primary time deposit instrument is called the euro-dollar. This is where dollars are deposited in banks outside the United States. Banks borrow dollars from each other by issuing euro-dollar time deposits. These are essentially short-term unsecured loans. In London, the rate on such dollar loans is called the LIBOR or London Interbank Offer Rate, and this is an add-on rate, and you really need to understand what this means. When we talk about 90-day LIBOR and we say that 90-day LIBOR is 4%, this 4% is a annualized number, which means that if we de-annualize by multiplying this by 90 over 360, we get 1%. So the rate for 90 days is 1%. A bank which borrows 100 million on day 0 will owe 101 million at the end of 90 days. Notice that the 1%, which is 1 million in this scenario, is added on to the principal of 100 million. This is as opposed to what we see with T-bills, where when we talked about a 4% discount, we had a par value of 100 and 4% discount was an annualized number. When we took that over a 90-day period, de-annualized it became 1% and the actual price was 99. So the interest amount that we calculate of 1 is deducted or subtracted from the par value or discounted from the par value in order to come up with the price. So with T-bills, we have a rate which is a discount rate. With LIBOR, the rate is an add-on rate. And as a general point, just like we have LIBOR, which is for dollars, if we talk about the euro market, then Euribor is the rate which is analogous to LIBOR, where the currency is the euro. Now let's talk about the concept of forward rate agreements. Forward rate agreements, or FRAs, are contracts in which the underlying is an interest payment. Here is a simple example of a forward rate agreement. Let's say that here at time 0, you get into an agreement with a dealer where you will borrow 100 million after 1 year, and that borrowing will be for a 1-year period. Now this loan actually is generally called a hypothetical loan because you might not actually borrow this money, but the contract says that the rate that you are locking in is 5%. So no matter what the interest rate at this point, you will pay 5%. The underlying is a 1-year loan. Notional principal is 100 million. When you come to this point 1 year later and the actual market rate is 7%, then you benefit from this contract because you will get to borrow 100 million at 5% even though the market rate is 7%. On the other hand, if the market rate falls below 5%, let's say to 4%, then you lose because even though the market rate is 4%, you still need to borrow at 5% because that is your contractual obligation. Let us look at some basic FRA notation and how to interpret that notation. When you see notation such as this, 1/3, 1 refers to a 30-day period. So a 1/3 means an FRA which expires at the end of period 1, which is 30 days later. The 3 means that the underlying hypothetical loan expires at the end of month 3. This is month 3 from time 0, and in terms of days it would be 90. So as you see here, the contract expires in 1 month. The underlying is 60-day LIBOR because this period here is 60 days. 3/9 means that the contract expires in 3 months, and 9 is 9 from time 0, which means that this period over here is 6 months or 180 days. So here we will have 180-day LIBOR. Now before you move on, I want you to fill in the question marks. 12/18. Here is what you should do. This is time 0. The contract expires in 12 months and the underlying should be a 180-day LIBOR because this is 18. So this period then becomes 180 days and the rate here then would be 180-day LIBOR. Now let's work on this example. You expect to receive 15 million in 90 days. So if this is time 0, you expect to receive 15 million over here, which you will invest, but you expect interest rates to fall. In order to hedge this risk, you decide to use an FRA that expires in 90 days and is based on 90-day LIBOR. Since we are talking about a 90-day LIBOR, then this period is 90 days. Since you are getting 15 million and you will be investing this amount, what you need to do is take a short position. Why? Because you would rather lock in your rate at which you are investing rather than face the risk of interest rates falling. So you get into a forward rate agreement which is quoted at 5%, which means that here at time 0 you lock in the rate of 5%. The notional principal obviously is 15 million given this data. The FRA expires over here, so that will also be specified in the contract that the FRA expires at this point in time. Now, when you come to day 90, let's say that the actual rate is 4.5%. So you are right, rates did go down. You will be investing 15 million for 90 days at 5%, even though the market rate is 4.5%. And remember, all these numbers that are given are annualized numbers. So let's quantify your benefit. With an FRA, the benefit is paid to you here, but we need to calculate that benefit. If you look at the difference between the contract rate and the market rate, that difference is 0.5%. But this 0.5% is an annualized number because both 5% and 4% are annualized numbers. You divide by 4 to give you a de-annualized number because this is a 90-day period, which is 1/4 of a year. So you divide by 4, and then to convert the percent into an actual currency number, you multiply by the notional principal, which is 15 million. So the benefit to you is 18,750. But since interest is paid at the end of the relevant period, this benefit is at this point in time. So 18,750 is the benefit over here. If we want to settle the contract over here, then what needs to happen is the other party or the counterparty needs to pay you over here. Obviously, they will not pay you 18,750. What they'll pay you is the present value of 18,750. So we take 18,750 and discount back 90 days using the market rate over here. And the convention used with FRAs is as follows. The present value is going to be 18,750 divided by 1 plus the market rate, which is 0.045, and then this needs to be de-annualized. So we multiply this by 90 over 360 and you come up with your answer. That answer is 18,541. So that is the payment that the long will make to the short. The terminology. The terminology here for this FRA is going to be 3 by 6. And why do we say that? This is 90 days, which means 3 months. This is 180 days, which is 6 months. And in terms of our terminology, we specify the point at which the FRA expires and the point at which the hypothetical underlying loan matures. Next, we come to currency forward contracts. Currency forward contracts are commitments to buy or sell a certain amount of a foreign currency or a fixed amount of another currency in the future. Here is a simple example. Let's say that you are based in the United States and operate in dollars. After 6 months, you will need to make an investment in Europe for which you will need 100 million euro. So you are concerned with the exchange rate risk. You are concerned that after 6 months, the euro will become too expensive. So you can go to your dealer and you can lock in a rate for the euro. So at time 0, you can lock in a rate for the euro. So let's say that you lock in a rate of 1.2000 for the euro. And obviously a notional principal needs to be specified. So you lock in this rate that on a per euro basis you will pay $1.2000 for a notional principal of 100 million. Now, no matter what the euro dollar rate might be at this point, you will get your 100 million euros at this particular rate. Let's look at an example. You are the CFO of a US based company and you expect to receive 20 million euros in 90 days. Let's say that this money is coming from your European subsidiary. A dealer provides a quote of 1.200 for a currency forward contract which expires in 90 days. In order to hedge your currency risk, should you enter the contract to buy euros or sell euros? Now think about it. You are a US company and at the end of 90 days, you will receive euro. Since you are a US company, you will be reporting your numbers in dollars. So you want predictability in terms of how many dollars you will get. So on day zero, what you will probably do is get into an agreement where you are selling euro at a given price. Here that price is 1.200. What this means is that when you get your 20 million euros, and that 20 million also needs to be specified in the contract, you can go to the dealer and sell the 20 million euros at $1.2 per euro. So the answer here is that you will enter into a contract to sell euros. Now at the end of 90 days, the actual rate is 1.25. Are you happy or not? In the context of this particular contract, you are not happy because you will be selling euros at the contract price of 1.20. Had you not gotten into this contract, then you would be selling at the market price of 1.25. So on a per euro basis, you are losing $0.05. The total loss would be 0.05 into 20 million, which is 1 million. This is the amount of money that you lose because of the contract that you got into. The question might be, why did you do this? And the answer is fairly straightforward. On this day, you did not know whether the euro will strengthen or weaken. And in order to hedge your risk, and in order to have certainty about the amount of dollars you will have, you got into this contract. Since this is cash settlement, you will actually need to pay $1 million to the dealer. That brings us to the end of this reading. Here are the main points that you need to know. You need to understand the basic concept of a forward contract, where at time zero, you get into a contract related to an underlying asset. The contract is signed at time zero. The contract expires at a later point in time. When the contract expires, the long needs to receive and the short needs to deliver. That is if we have a deliverable oriented contract. If it is a cash settled, then obviously a cash payment is made from one party to another. If the price goes up, then the long is happy. If the price goes down, then the short benefits. Long and short, as I alluded to, the long party is the party that is getting into the contract to buy the underlying asset, and the short party is the party that is getting into the contract to sell the underlying asset. We talked about dealers and end users. Dealers tend to be large banks or other financial institutions. End users tend to be corporations or governments or NGOs. In an equity forward contract, the underlying could be a stock, it could be a portfolio, or it could be an equity index. In bond forward contracts, the underlying is a bond or a portfolio of bonds. We talked about the London interbank offer rate. This is the rate that banks in London charge each other on dollar deposits. So it is a rate paid by private parties, where the private parties have a very strong credit rating. Forward rate agreements are essentially forward contracts where the underlying is an interest payment, and currency forward contracts are contracts where the underlying is a currency. As always, read the summary in the curriculum. It's very good. Review the learning objectives. Unfortunately, this reading doesn't have the boxed examples. There are a few practice problems. There is a lot of emphasis on forward rate agreements. So go over the few examples or practice problems in the curriculum and try to do as many practice questions as possible from other sources. That is it.